Now this question, which is from question 1, 2019, paper 1 of the AQA exam board, we're given two triangles and we're told certain things about these triangles. We're told that no sides, so the sides for this triangle are different from this one, but two angles are the same. Now, if we've got two angles the same, two right angles and two angles that are both the same, that means that these triangles are not the same size, but they are the same shape, because it ultimately means that that angle and that angle are the same. And you can have three exactly the same angles, but the two objects, the two triangles, can be of different sizes. So what we've got to do is to recognise that this question is a ratio question. First recognise, okay, what have we been given? Two angles the same. We've also been given three sides. If we've been given 3 out of 4 of the sides, that means we can find the fourth side using ratio. So the first thing you're being tested on is, do you recognise this is these are similar triangles? Similar triangles, similar two-dimensional shapes, are shapes that are the same shape but different sizes. The next thing is, do you recognise this is a ratio question? Once you've done that, then we can see if it's a ratio question, we need to figure out what have we done to the 10 to make it 15. Now, what we've done is, remember, in ratio, we're dealing with multiplications and divisions, not additions or take away, because proportionality is about multiplication and division. Okay, so it wouldn't work if we just add 5, even though it looks like we've just added 5. If we just say, well, we add 5 to the 6 to make this, then that wouldn't work, because the triangles would then be out of proportion, because we need to see that 6 over 10 has got to be the same as this. So another way of writing this would be 6/10 has got to be the same as y over 15. So that's a fractional way of writing this ratio. So we can use either the fractional method or we can use this method. From the fractional method, it's a little bit easier to see that we're dealing with, okay, equivalent fractions. And if you're not sure about equivalent fractions, then go to the equivalent fractions video and have a little revision of that. Let's do it the fractional way first then. We can actually reduce 6/10 to, well, if we divide them both by 2, we get 3 over 5. And that has to be the same as something over 15. Now we're in a little bit of an easier position, because we can see, well, to get from 5 to 15, we've actually multiplied by 3. So we've got to do the same to the top to make this equivalent, if you like, to this. If we've multiplied the denominator by 3 to keep it as an equivalent fraction, we have to do the same to the numerator. So therefore, y is equal to 3 times 3. So y is equal to 9 centimetres. So that's the fractional way of doing this, using fractions and equivalent fractions. So as well as a ratio question, you can also recognise it as an equivalent fraction question. If we were to do the ratio method, we're simply saying, well, 15 is times 1.5. So we can see that to get to 15 from 10, we've multiplied 10 by 1.5. That's the same as 1.5 or 3 over 2. So if we multiply 6 times 1.5 to get the same equivalent ratio here, to get that y, then we can see, well, 6 times 1 is 6, add another half is 9. So I'm just going to partition that off so that you can see this is the ratio method. Ratio method. Don't know if you can see this on the video. Has it come out? Sort of, not really. And this is the fractional method. Okay. So there you go. That's question 1. I hope that's helpful. And just have a look at those. And whichever way you do it, As long as you reach the right answer and you've got a clear method, then stick with that method and do it the way that you feel most comfortable with.